Welcome to Brilliant Maths, where every student has an opportunity to excel in maths. Go to our website, subscribe to it, and get access to all the materials that are there for you. Watch the videos and subscribe to the videos. You'll find them very useful. Today we'll be looking at Introduction to Algebra. What exactly is algebra? Algebra involves the use of letters and symbols to represent numbers. For example, we're saying 5a, 2p, 7z. Those letters and numbers together is actually what we call algebra. And we'll be looking at the language of algebra, algebraic language, vocabulary, and symbolic expressions. So that when you see those words, you will know what they mean. Variables. What are variables? The letters that represent values or numbers are called variables, e.g. 14D, 20F, 17Q. D, F, and Q are variables. Another name for variables is pronumeral. In some books, they refer to the variables as pronumerals, so you don't think that they're two different things. Variables and pronumerals are the same. Then expression. What are expressions? What are algebraic expressions? An algebraic expression is a combination of letters or variables and numbers using any one or more of the four operations: addition, subtraction, multiplication, division. So for an example of an algebraic expression is 3c plus 7, or 2x plus 5y minus 11p. When these letters are assigned values, then the value of the expression will change. Expressions do not have equality sign. So for example, 3c plus 7 has a value of 10 if c is equal to 1. That same expression would have a value of 37 if c is 10. Because 3c will then become 3 times 10, which is 30 plus 7. But expressions do not have equality signs. That's what differentiates an algebraic expression from an equation. So what are equations? An equation is a combination of letters, numbers, one or more operations, and an equal sign. So when you have an algebraic equation, you can find the value of the unknown. For example, we have 3a plus 7 is equal to 22. What is the value of this a? We can find the value of this a from this equation. If 3a plus 7 is 22, that means that 3a is equal to 22 take away 7. And 22 take away 7 will be 15. So 3a is 15. And if 3a is 15, the value of a then will be 15 divided by 3, which is 5. So in this equation, the value of a is 5. And to show that that is correct, 3 times 5 is 15, and 15 plus 7 is 22. So that's an example of an equation. Another one is 5 minus x is equal to 4x. What is the value of x? If we take x from this side of the equation to the other side, it becomes 5 is equal to 4x plus x. So 5 is equal to 5x. So here the value of x is 1. And to show that that is correct, 5 minus 1 is equal to 4, because the value of x is 1. So the next equation is 2b minus 8 equals 40. So what is the value of b in this equation? It implies that 2b equals 40 plus 8, which is 48. So if 2b equals 48, then b is equal to half of 48. And half of 48 is 24. So the value of b in this equation is 24. The next vocabulary we'll be looking at here is terms. What are the terms in an equation or expression or in a formula? These are the separate parts of the expression or the equation or the formula. For example, in the expression 13a minus 5b minus 9, it has three terms: the 13a, the minus 5b, and the minus 9. Those are the three terms in that expression. So the next vocabulary we'll be looking at is formula. What is a formula? A formula is an equation with more than one variable in it. For example, y is equal to ms plus c. That's the formula for finding the equation of a straight line. C squared plus a squared plus b squared, Pythagoras theorem. A is equal to b times h over 2, or base times height over 2. That's the formula for finding the area of a triangle. So a formula has more than one unknown or more than one variable in it. In this segment, we want to learn how to identify the operation given an algebraic problem. So what are the vocabulary you'll be looking out for to use the minus sign? Minus. You see words like difference between, fewer than, from, decreased by, less than, less, take away, and so on. When you see these particular vocabularies, then you know that your operation is subtraction or take away. For example, what number is 2 less than y? So, it's y less than, take away 2. That is different from what number is y less than 2. Y less than 2 will be 2 minus y. Example B. A number is decreased by 5. What is that number? So first and foremost, you would say let the number be X or A or B or C. The choice of the alphabet is yours. So let the number be A. So a number is decreased by 5. That means A is decreased by 5. So we have A minus 5. What is that number? So that number is actually A minus 5. So the value of that number depends on the value of A. So if I choose A to be 6, 6 decreased by 5 is 1. If I choose A to be 20, 20 decreased by 5 will be 15. I hope that is clear. Thirdly, the difference between a number and 8. So let that number this time be P. So the difference between P and 8 will be P minus 8. So it's important to know what operation to use. And when you see these words, these various words, difference between, decrease by, less than, less, take away, fewer than, and so on, you know that you are supposed to subtract. Next, we want to identify the words that will mean addition. When do you use addition? What words do you see or read in a word problem that will mean addition? Words like plus, and, increased by, total, added to, greater than, sum of, more than, and so on. So for example, k more than x. It means that the number is more than s by k. So that number will be s plus k. So k more than s means s plus k. 3 and a number. We don't know what the number is. So you say, let the number be any alphabet of your choice. Let the number be C. So 3 and the number would mean 3 plus C, because I have chosen C as my unknown. Next, a number increased by 4. So let the number be P. That will mean P is a number and is increased by 4. So it will be P plus 4. The next example is the sum of the length and width of a rectangle. So we need to choose alphabets or letters for the length and the width. We don't know what the length is, we don't know what the width is. So let the length of the rectangle be x and let the width be y. So the sum of the length and the width of the rectangle will be x plus y. So these are the words that would mean addition in a word problem involving algebra. Next, we'll be looking at the different words or vocabularies that mean multiplication. So words like times, double, twice, product or product of, at, triple, fractions of, multiply, and so on. Whenever we see any of these words in a word problem, they actually mean multiplication. So for example, 5 times a number. So the first step is to choose a letter for that number. So for example, we say let the number be P. So 5 times P will be equal to 5P. So 5 times a number means 5 times P. Next, the product of 7 and a number. So let the number be F. The product of F and 7 means 7 times F, because product means multiplication. It means times, which is equal to 7F. And next we have double the number. So let our number be C. So double C will mean C plus C, which is the same as 2C, and that is also the same as 2 times C. I need you to understand that. Double a number means add the number to itself or multiply the number by 2. So whichever one you choose, it means 2C. 2/3 of a number. Let our number be Z in this case. 2/3 of Z. 2/3 times Z. That is equal to 2Z over 3. It's multiplication. X multiplied by itself, it means x times x, which is equal to x squared. So these various vocabularies, times, triple, fractions of, multiplied, product, double, they all mean multiplication in a word problem. Next, we are looking out for vocabulary words that would mean division. Words like quotient, or quotient of, divisible by, half of, share, divide, pair, goes into. All these are words that mean division in word problems. So for example, half of a number. So to write that expression, half of a number, first let the number be b. So when you say let the number be b, half of b will be b divided by 2, which is the same as b over 2. Next, the quotient of 5 and the number. So let that number be p. So let the number be p. The quotient of 5 and the number would mean 5 divided by p, which is equal to 5 over p. And this is different from the quotient of a number and 5. So if we had the quotient of a number and 5, and we say let our number be p, that would have been p divided by 5, which would be p over 5. So take note of that. The quotient of 5 and a number, and we decide to make the number p, is 5 over p. A number goes into it twice. What is that number? So let that number be c. That number goes into 8 twice. That means that if you divide 8 by the number c, you would get 2. And what is that number? That means, this is an equation now, 8 over c is equal to 2. So that means that 2c is 8, and c is equal to 4. And 4 is a number that divides 8, and you will get 2. The price of potatoes is 12 pounds per 10 kilograms. Per means divide, because we have 10 kilograms here, costs 12 pounds. What is the cost of 1 kilogram of potato? So we are dividing 12 pounds by 10. And if we do that, that will give us £1.20. So each kilogram would cost £1.20. In this segment, let's look at word problems involving algebraic expressions. The first example we have is a piece of wire is 33 centimeters long. 3 pieces of wire, each of length z centimeters, are cut from it. Write the expression for the length of wire left. So we're saying that the total length of the wire is 33 centimeters. It's a word problem, so I would like to write statements. Total length of wire equals 33 centimeters. 3 pieces of wire, each of length z centimeters. Each of them is z. We don't know what z is. That's our unknown. That's our letter. And there are 3 of them. So length of each of the ones that have been cut out is equal to z. So if there are 3 of them that were cut out, so z centimeter plus z centimeter plus z centimeter, that becomes equals 3z centimeters. So a total of 3z centimeters have been cut out from the length. Write the expression for the length of wire left. So what will be left after 3z is taken from 33? Length wire left is equal to 33 minus 3z centimeters. We can't find this length unless we give a value to z. So depending on the value of z, we can find the length of wire that is left. So for example, so let z be 5. This was not part of the question, it's just an extension. So let z equals 5 centimeters. Therefore, 3z will be equal to 5 times 3 centimeters, which is equal to 15 centimeters. That means that 15 centimeters of wire has been cut out of the 33 centimeters. So, how many centimeters of wire is actually left? We have finished finding the expression. We have given a value to z to be able to find the actual length of wire left if z is equal to 5 centimeters. So now we have length left, length of wire left is equal to 33 centimeters minus 15 centimeters, and that would be equal to 18 centimeters. So if z is equal to 5 centimeters and we cut out 3 pieces of wire 5 centimeters long from 33 centimeters length of wire, would have 18 centimeters of wire left. In this example, Emmanuel earns $M a week working in a factory. How much does he receive in 3 weeks? So that means that for every week he earns $M. So he works another week, he earns $M. The third week he earns $M. So for 3 weeks of work, how much would he earn? M plus M plus M. That will be the total amount he would earn in 3 weeks. And that's the same as $3M in 3 weeks. How much will he earn in 7 weeks? This time we can go directly and multiply our $M by 7. So we get 7 times $M, and that will give us $7M in 7 weeks. In a fortnight is 2 weeks. That will be 2 times $M, and that will be equal to $2M. In a year, how much would he earn? First, you need to know how many weeks are in a year. There are 52 weeks in a year. So we have 52 times $M, and that will be equal to 52 $M. And then he gets a pay raise of $R. How much will he earn per week? This last question says, how much will he receive per week if he receives a raise of $R per week? So initially he earned $M, and then he gets a raise of $R. So his new weekly pay will be M plus $R. So that will be $M plus $R a week, and we have M plus R dollars weekly. That will be his new weekly pay after the raise. Let's look at this example. A farm has X cows and Y chickens. First, write an expression for the number of legs on the farm, excluding the farmer. And secondly, if 10 more cows and 15 more chickens are brought to the farm, write the expression for the number of legs. So we have a two-step problem here. First, we have X cows and Y chickens. How many legs does a cow have? A cow has 4 legs and a chicken has 2 legs. So, in the first one, when you have X cows and Y chickens, the number of legs would be 4x, because a cow has 4 legs, and so that's plus 2y legs. So the number of legs on the farm, excluding the farmer, will be 4x plus 2y. That is 4 times the number of cows plus 2 times the number of chickens. That will give us the total number of legs on the farm. And then secondly, if 10 more cows and 15 more chickens are brought to the farm, the 10 new cows have 4 times 10 legs, which will give us 40. And the 15 new chickens have 15 times 2 legs, which will give us 30. So 40 plus 30 is 70. So we now have an additional 70 legs on the farm. The new expression for the number of legs on the farm would then be 4x plus 2y plus 70 legs. So the actual number of legs on the farm would depend on the number of cows and the number of chickens. For more examples, exercises, and feedback, subscribe to brilliantmaths.com. You will get lots and lots of exercises to help you in math. And for this particular topic, request for Module 3. Watch our videos and subscribe to our YouTube channel. I am Ngozi, Orevaoghene, and always remember, maths is fun.